Question 3a part 1, show that z minus I times z is equal to 8 minus 4i. So z is given as 6 plus 2i, so 6 plus 2i, so I'm substituting that in for z. Then I'm going I times z, well I'm substituting in 6 plus 2i for z. And hopefully when I multiply all that out and simplify, I get 8 minus 4i. So the first one stays as 6 plus 2i. I'm going to multiply in this I now, which is going to give me minus 6i minus 2i squared. And again, I want that to equal 8 minus 4i. Minus 2i squared. So I squared, it tells us in the question, to change that to minus 1. And I can group the positive 2i and the minus 6i to get negative 4i here, and then the 6 at the front. So that's giving 6 minus 4i plus 2 is equal to 8 minus 4i. And if we tidy that up a little bit, we have 6 plus 2 is 8. And subtract 4i. So 8 minus 4i is equal to 8 minus 4i. So part A, part 1, I've proved it's true. Part 2. Show that the modulus of z squared plus the modulus of iz squared is equal to the following. So just take your time with this one. There's 3 parts to it. First part I'm going to do is I'm going to work out the modulus of z squared. So we do know that z is equal to 6 plus 2i. That's what we're given in the question. Now the modulus formula is given by the square root of a squared plus b squared. So that's the formula for the modulus. A is the real part, so that's the square root of 6 squared, plus b is the imaginary part, that's the 2. We don't put in the I. So that's giving me the modulus of z is equal to the square root of 36 plus 4, which is the square root of 40. So that's the modulus of z. Now the question wants us to find the square root of the modulus of z, or sorry, the square of that. So I'm squaring the square root of 40, which is giving me a value of 40. So that's the first part done. Let's come over now and look at the next part, which is going to be the modulus of I times z all to be squared. Now, go back up to the top of the question here, part 1. Do we know what I times z is? We do. We part worked it out. Well, we had a minus in front of it, so let's do it again. So iz is I times z, which is 6 plus 2i. Multiplying in the I, you get 6i plus 2i squared. 6i minus 2 times minus 1. 6i plus 2. Rearrange it, real part first, so 2 plus 6i. So that's the value of iz. I now need to get the modulus of iz. So once again, a squared plus b squared is my formula. And working that out now, sorry, a slight little mistake up there in the top of the question. It's 6i plus 2i squared. So just change, if you're following my work there, that's a minus 2 and that's a minus 2. So minus 2 plus 6i. So the modulus of I squared is equal to the square root of minus 2 all to be squared plus 6 all to be squared, which once again is giving me 4 plus 36, which is the square root of 40. And once again, they want us to get the square of that. So it's the square of the square root of 40, which is equal to 40. And you can see that that's the same as the modulus of z squared. Now let's come over and do the third one. The modulus of z minus I times z all to be squared. So filling it in, we have z, which is 6 plus 2i. I'm then subtracting I times z. Well, we have that from part 2, which is minus 2 plus 6i. So that was the second part we just did. Multiplying that minus into this bracket here. So that would give me 6 plus 2i, minus by minus is plus 2, minus by the positive gives me a negative 6i. Tidying all that up would give me 8 minus 4i. And I now need to find the modulus of that. So it's z minus I times z to be squared. So that's giving me the square root of a, which is 8 squared, plus b, which is minus 4 to be squared. Let's just get rid of that square there for a second. We'll worry about that in a minute. That's giving me 64 plus 16, which is the square root of 80. Now we'll worry about the square. So it's z minus I times z, all to be squared. So I'm squaring the square root, which is positive 80. And you can hopefully see now that we're practically there. My last little step is just to come back to the very start of the question because it says show that. So I need to show that the modulus of z plus the modulus of iz is equal to the modulus of z minus I times z, all to be squared. So what did we get z squared to be? We got it to be 40. I times z, all to be squared, we also got to be 40. And the value for the right hand side, we got to be 80. And here I've got 80 is equal to 80. So therefore true. A part 3, the circle C passes through the point Z, IZ and 0 as shown in the diagram below, not to scale. Z and IZ are endpoints of the diameter of the circle. Find the area of the circle C in terms of pi. The space on the next page, I'm just going to work both of them, or my answer out here around the circle just so we can follow the steps and use the diagram for assistance. So let's fill in everything we know. So O is the origin, so that's obviously going to be 0, 0. The point IZ we found out in part 2 to be minus 2 6i, so that's a positive 6i, so that's that coordinate, and the coordinate of z is 6 plus 2i. So that's everything we know. We know actually the distance from the origin out to z is the square root of 40 because that was the modulus from part 2. The modulus stands for the distance from the origin to the coordinate. And we also know that the distance from the origin to I times z is also square root of 40. So that's everything we know. Now there's two ways we can work out the area of the circle. Well, in order to find the area of a circle, first of all, we need to get the radius because the formula for the circle, area of a circle, is given as pi r squared. So in order to get the area, we need the radius. So to get the radius, there's two ways of doing it. I'm going to do option 1 over here and option 2 on this side. Option 1 is simply just to get the distance from the two coordinates, z and iz, and then half that distance to get the radius because I'm getting the diameter here. So if I take my 2 points are minus 2 plus 6i and 6 plus 2i. And I use the distance formula for my log tables, x2 minus x1 all to be squared, plus y2 minus y1 all to be squared, all in a square root. Label my 2 points, x1, y1, x2, y2. Filling that in, I get, what are we getting? We're getting 6 minus minus 2 plus 2 minus 6. Again, I don't need to put in the i's here, which is giving me a distance of 8 squared, which is 64, plus minus 4 squared, which is 16, which is giving me a distance of the square root of 80. Yeah, okay. Actually, we have that up from part 2 as well, but nonetheless, we've done it out. So the distance between my 2 points on the circle is the square root of 80. Now, another way you could have done that is looked at the triangle in the circle. This would be IZ, down to Z, back to the origin. The triangle which goes through the diameter of a circle and touches the point on a circle is a 90-degree triangle. So we could have used Pythagoras' theorem here also to get the square root of 80. Let's just do it out to be sure. So this would be my C here, the hypotenuse. So C squared is equal to square root of 40 squared plus the square root of 40 to be squared, which is 40 plus 40 equals C squared. C then is equal to the square root of 80. So both options are fine. Let's come back now and find the area of the circle. So just to be clear here, the diameter is equal to the square root of 80. So the radius is equal to the square root of 80 divided by 2. Wouldn't that be right? Which is, on my calculator, 2 square root 5. So the radius is 2 square root 5. So filling that in to my area of the circle, pi times 2 square root 5, all to be squared, wants it in terms of pi. So that's an area of pi times 2 square root 5, all to be squared, which is giving me an area of 20 pi units squared, because we don't know if it's centimeters or anything like that. So 20 pi is our answer here. B, square root of 3 minus I to the power of 9 can be written in the form a plus ib, where a and b are elements of z and I squared is minus 1. Use de Moivre's theorem to find the values of a and the value of b. So if I'm using de Moivre's theorem here, first thing I need to do is write my complex number in polar form. So I need to convert the square root of 3 minus I into polar form. So that's my first step. And my a here is the square root of 3. My b is the number in front of the I, which is negative 1. My polar form is r times cos of theta plus I sine of theta. The radius then is given by the square root of a squared plus b squared, the modulus. And that's giving me square root of 3 all to be squared plus minus 1 all to be squared in a square root. So my radius here is the square root of 3 plus 1, which is the square root of 4, which is 2. So r is 2. Next thing I need to do now is find my angle, my theta, my argument. So that's giving me theta is equal to tan inverse of b over a. So the angle is equal to tan inverse of minus 1 over the square root of 3, which is giving me minus pi over 6, or 1/6, minus 1/6 pi. I'm going to work to the positive here, so I'm going to add on 2 pi here. I don't want a negative solution. So that's giving me a theta, an angle of 11 over 6 pi. So if I come over now and fill that into my polar form, r times cos theta plus I sine theta, filling in my r, which is 2 times cos of 11 over 6 pi plus I sine 11 over 6 pi. Okay, next thing I need to do now is come back to the top of the question. What does it want? It wants us to evaluate it when it's to the power of 9. So I'm looking for the square root of 3 minus I to the power of 9, which is the same as my polar form, 2 times cos of 11 over 6 pi plus I sine 11 over 6 pi, all to the power of 9. Now, if I use my de Moivre's theorem, it simply just tells me to put the 9 to the power of the 2, the r, and then I multiply the angle by 9 as well. So that's then going to be cos, I'll just change the color here so you can see what's happening, 9 times 11 over 6 pi plus I sine 9 times 11 over 6 pi. And 2 to the power of 9 is giving me 512 times cos of 33 over 2 pi. So when I multiply 11 over 6 by 9, plus I sine 33 over 2 pi. Make sure your calculator now is in radians form, so I need to multiply in this 512, and that's giving me 512 by cos 33 over 2 pi is 0, and multiplying 512 by sine 33 over 2 pi is 512, because sine 33 over 2 pi is 1, and don't forget to put back in your I, and that's us finished. So A in this case would be 0, B would be 512.